Good evening, children.
Good evening, ma'am.
Good evening, ma'am.
Ma'am.
Good evening, Raja. Good evening, Madhumita. Good evening, Jayant.
Good evening, ma'am.
Yeah, I can't identify the other person.
Ma'am, I'm Krishmika, ma'am.
Oh, hi, Krishmika. Good evening.
Good evening, ma'am.
Yeah. So the others will be joining us on Saturday. All right. So let's begin our session today. So we will be starting off the first chapter in NCERT, number systems. So to begin with, let's understand the definitions or the meaning of certain important terms. All right. Am I audible? Am I clear to everybody?
Yes, ma'am.
Yes, ma'am.
All right. All right. Fine, children. Tell me, what do you understand by this term natural numbers? What do you understand by the term natural numbers? Counting numbers are called natural numbers. Can we say that? Counting numbers are called natural. Don't write anything. I'll share the notes with you on WhatsApp later. You need not write anything in today's class. All right, I'll share the notes later. So just listen to me carefully. The counting numbers are called natural numbers. Counting numbers are called natural numbers. Because say some objects are lying on your table, you know, or there are some objects lying on a table. How do you count them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did we say 0? Disable your mic, child, whoever it is. Please disable your mic. Did we say 0, then 5, 8, 20? Did we say that? No, we said 0. I'm sorry, we said 1, 2, 3, 4, 6, 7, 8, 9, 10. Yeah, I can see one other person in the meeting. Who was that? Who just joined?
Ma'am, S. Gautam, ma'am.
Gautam. Okay.
Yes, ma'am.
Good evening, Gautam.
Good evening, ma'am.
Yeah. All right. So, all of you, please disable your mic. Please put your mic on mute. You can unmute your mic when you have to ask or say something. All right. So that's how we count. That's how we count. So we say 1, 2, 3, 4. Counting numbers are called natural numbers. Counting numbers are called natural numbers. Is that right?
Yes, ma'am.
Yeah. So how do you represent them on a number line? See here. 1, 2, 3, 4, 5, 6, 7, and so on. These are natural numbers. These are natural numbers. Whole numbers. Whole numbers. So the collection of all natural numbers, including 0. The collection of all natural numbers, including 0. The collection of all natural numbers, the collection of all natural numbers, including 0, forms the collection of whole numbers. Forms the collection of whole numbers. So all natural numbers, including 0. All natural numbers, including 0, form the collection of whole numbers. Integers. Integers. Are we see them on a number line? See you. So, see, this is one way of understanding the collection of all natural numbers, their negatives. The collection of all natural numbers and their negatives. Okay, before I say that, what's the negative of 3? What is the negative of 3?
-3, ma'am.
-3. What is the negative of -5?
-5.
5.
5. The negative of -5 is 5. What's the negative of 10?
-10, ma'am.
-10.
What's the negative of -25?
25, ma'am.
25.
25. So our number, the sum, see here, this is a number, this is its negative, this is its negative. The sum of a number and its negative should be 0. See, this is the number, this is its negative. The sum of a number and its negative is 0. This is a number. This is its, the sum of a number and its negative is 0. Again, there's a number, this is its negative. When you add these two, the sum meaning when you add these two numbers, -25 plus 25, the sum is 0. But when you say, if you thought the negative of -7 is -7, supposing you thought that, because we feel negative means there should be a minus sign. Okay, see, because we feel if it's negative, there should be a minus sign. So if you thought -7 is -7, supposing, okay, now add them and see, add, you should get 0. That means your answer is correct. Now, this is the number, this is the number, and you think that this is the negative of the number. Okay, now add these two numbers, add the number and it's negative. What is the sum? It's -14. That means your answer is wrong. You're wrong in saying the negative of the given number. So -8, the number is -8. And you think the negative of -8 is -8. Add these two numbers. What's the result, children? What is -8 minus 8?
-16.
-16, -16. So what should be the negative of -8? So that the sum is 0?
8.
8.
8 minus 8 plus 8 is 0. So we say that -8. So if the number is -8, 8 is its negative. If the number is 8, -8 is its negative. The negative of 8 is -8. The negative of -8 is 8, because only then the sum will be 0. Only then the sum will be 0. So talking about integers. Talking about integers. All right, talking about integers. So these are the collection of natural numbers. These are the negatives of the natural numbers. See here, the negative of 1 is -1. The negative of 2 is -2. The negative of 3 is -3. And so on. The negative of 4 is -4. So the collection of all natural numbers, their negatives, including 0, forms the collection of integers. Forms the collection or makes the collection of integers. We all know that there are infinitely many natural numbers. You know the smallest natural number is 1. You do not know the biggest natural number, which is the greatest natural number. We don't know. You can't say. The smallest whole number is 0. The largest whole number, no, we can't say. But when it comes to integers, you cannot even say the smallest integer, not the largest integer. Which is the smallest natural number, children? Which is the smallest natural number?
1.
1.
Class, which is the smallest? Yes. Which is
1,
the
ma'am.
smallest natural number?
1. 1, ma'am.
Ma'am.
The smallest natural number is 1. Which is the smallest whole number?
0.
Zero,
ma'am.
ma'am.
0.
0.
Zero.
Which is the biggest natural number? Can't say.
Yes.
Which is the biggest whole number?
We cannot say, ma'am.
Can't say. Which is the smallest integer?
Yes, that, ma'am, that also we cannot say, ma'am.
We can't say the smallest integer, nor can we say the largest integer. So when it comes to integers, you don't know where it starts, where it ends. But we know natural numbers start from 1. We know whole numbers start from 0. But we do not know, you cannot say where integers start. You don't know the starting point or the ending point of an integer. This is how we represent them on a number line. So what do you see? Let me show you again. So we have the natural numbers. We have the natural numbers. We have their negatives. The negative of 1 is -1. The negative of 2 is -2. The negative of 3 is -3. The negative of 4 is -4, and so on. So the collection of all natural numbers, their negatives, including 0, forms the collection of integers. Forms the collection of integers. Do we get it, children? Get the picture of this number line in your mind when you have to define integers. Okay, so you must see this in your mind. See this number line in your mind and look at you should visualize this. So the collection of all natural numbers, their negatives. See the negatives. These are the natural numbers and these are the negatives. Negative of 1 is -1. Negative of 2 is -2. Negative of 3 is -3. Negative of 4 is -4. The collection of all natural numbers, their negatives, including 0, forms the collection of integers. Got that, children?
Yes, ma'am.
Yes, ma'am.
Do we all get it?
Yes, ma'am.
Yes, ma'am.
Okay. So far we have seen natural numbers, whole numbers, integers. Next, rational numbers. Rational numbers. Again, you would have seen this definition last year. This was the first chapter in your NCERT textbook, rational numbers. Okay. Any number, see, nothing is difficult, okay? It's just that you should focus on what I'm saying. Don't think of something else. What you hear, process that in your mind. That's very important. Focus is very, very important. What you must process in your mind is what you hear from me. I'm saying something, right? So that's what you hear. Process the same thing in your mind. Don't think of something else. Then nothing can be understood. Even if I attempt to explain 100 times, we wouldn't understand if you do not extend your cooperation. So I'm trying to say something. Please process that carefully. Understand, try to understand. Any questions you can ask me anytime. All right, rational numbers, children. So if you can write a number in the form P by Q. Okay, before that, what is 0 by 3? What's the value? 0 divided by 3. 0 divided by 3. What's the quotient? What's the quotient when you divide 0 by 3?
0, ma'am.
3 zeros are 0. So the quotient is 0. What do we write as the answer? The quotient, right? What do we write as the answer? The quotient. See, when we are asked what is 25 by, okay, let me say, okay, so what is say 48 by 12? What is 48 by 12? What is 48 by 12, children?
4, ma'am.
4. What is that 4? Are we writing the remainder? No. 48 by 12. 12 fours are 48. 0 is the remainder. So when it's a complete division, that is the remainder is 0. The quotient is what we state here. Show here. 48 divided by 12. The quotient is 4. That's what we say is 4. 12 ones are 12 fours are 4. What is 0 divided by 7? So 0 divided by 7. 0 divided by 7. You'll have to put 0 inside. The numerator is the dividend. The denominator is the divisor. Always. Always. See here, when it's 48 by 12. When it's 48 by 12, 48 is the dividend. 12 is the divisor. 12 is the divisor. 12 fours are 48. All right. 4 is a quotient. Similarly, 0 by 7. 0 by 7. 0 is the dividend. 7 is the divisor. 7 zeros are 0. Finished. 0. The quotient is 0. The quotient is 0. So 0 by 7. 0 by 100. 0 divided by 100. 100, 0. 100 ones are 100. 100 zeros are 0. 0 by 100 is 0. But what's... So we know 0 divided by any number, 0 by 1, or 0 by 2, 0 by 3, 0 by 10, 0 by 50 is all 0. Is all 0. When the numerator is 0, it is defined. The value is 0. Now when you're dividing by 0, now supposing you have 50 by 0. Okay, so let's divide 50 by 0. 50 divided by 0. 0 ones are 0, 0 twos are also 0, 0 threes are 0. You cannot get anything. You can see you need to write a number which is exactly 50 or a number less than 50. But 0, whatever you do, you will not get.
Ma'am, it's not defined.
Yeah, it's not defined. The 0, how many times will give you 50? So whatever you do, 0 zeros are also 0. 0 ones are 0. 0 twos are 0. So division by 0 is not defined. Division by 0 is not defined. Let me write that. If the denominator is 0, if the numerator is 0, 0 by 100 is 0. 100 by 0 is not defined. Is not defined. Not defined. Not defined. 100 by 0 is not defined. What is 35? What is 35 by 0?
Not defined.
Not defined. When the denominator is 0, the division is not defined. When the denominator is 0, the division is not defined. What is 0 by 35?
0.
0, ma'am.
0. 0 by 35 is 0. 0 by 35 is 0. Remember this. When the denominator is 0, that division process is not defined. So coming to that, so now we understand that the denominator should not be 0. The denominator should not be 0. The numerator can be 0. The numerator can be 0. The denominator should not be 0. So now let's understand what are rational numbers. Let's understand what are rational numbers. So any number of the form P by Q. You can say A by B, or you can say M by N. Nothing that you should say P by Q. Anything, or you can say X by Y. Any number of the form. So you can take anything, children. You can say C by D. All right. So any number of the form, let me say P by Q. Okay. Let me say P by Q. Okay. So if you can write a number in the form P by Q, where P is an integer and Q is also an integer, but not 0, because denominator should not be 0. We just understood that. But not 0. Because what are integers? What are integers? These are integers. What you see on the number line like this, what you see here, there are many more numbers on the number line, children. Now from this representation, what you can see, goes on like that on either sides. The few numbers which you can see on the number line are integers, correct? Yes or no?
Yes, ma'am.
Okay, can we see natural numbers there negatives and 0. So this is how we represent integers on the number line. And this collection is, infinite because it extends indefinitely on both the sides. The collection extends indefinitely on this side and on this side. That is, the collection extends indefinitely to the right of 0 and to the left of 0. To the right and left of 0. Okay, so any number of the form P by Q, where P is an integer and Q is also an integer, but not 0, Q can be in both P and Q are integers, but the denominator Q should not be 0. Is called a rational number. Simple, just get this picture in your mind. If you want to define what a rational number is, just get this picture in your mind. P by Q, P integer, Q also integer only, but not 0, Get this picture in your mind. Or write this somewhere in the corner of your book. P by Q, P is an integer, Q also integer, but not 0, So use this and define. If you can express a number in the form P by Q, see, I'm just looking at this and explaining. I'm just looking at this. Say, I don't know the definition. OK, I'm just looking at this representation and, defining a rational number. Any number of the form P by Q. Or if you can express a number in the form P by Q, where P is an integer, Q is also an integer, but not 0, is a rational number. Integer, see, I'm writing it so many times for you. Okay, if you can express a number in the form P by Q, where P is an integer, Q is also an integer, but not 0, then such a number is a rational number. Now tell me, okay, let me explain a few, then I'll ask you. Now, supposing 0, okay, now 0. So now we have to understand if 0 is, see, one more thing is one number can have many names. Use the raise hand option, children. Raise your hand. Class, use the raise hand option. Raise your hand. Raja, Madhumita, others. Who's in the name? Anand Kumar. I forgot. Krishmika, is it?
Yes, ma'am.
Okay, Krishmika, Gautam, and Jayant. Jayant, where are you?
Ma'am.
Yeah. You can't use the emoji? Okay, that's good.
Ma'am.
No. I just asked you. You hadn't used the emoji to raise your hand. I just asked you why. All right.
Okay.
Now, children, let's understand if 0 is a rational number. Is 0 a rational number? See, how much you should have some rule to understand. Now in the exam, they will not ask you the very same question. The question will be different. So there should be some rule to decide. There should be some rule to decide if a number is a rational number or not. So what is the rule? This is the rule. This is the rule. Use this rule and check 0. Can you write 0 as 0 by 1? Giant, what is the question?
Ma'am, 0 by 0.
No. What is the question? What is my question? What are we trying to understand?
Ma'am, 0 by 1.
No, that's what is the question? What are we trying to understand?
Ma'am, P by Q.
No. Okay. Why? What is the question? My question is, what is the question? What are we trying to understand? Gautam? Who can tell me the question? What are we trying to understand? Yes, Gautam, what is the question? Who can tell me in the class? What is the question?
The question is 0 by 1 a rational number?
Before that, I said something. We are trying to understand if 0 is a rational number. Yes or no? That's what I said.
Yes.
We are trying to understand if 0 is a rational number. Is 0 a rational number? Is 0 a rational number? Is what we're trying to understand. Is 0 a rational number? Children, I've shared my screen. Hope all of you can see my screen. My screen is visible to all of you, right?
Yes, ma'am.
Yes, ma'am.
New students? Jayant, Gautam, Krishmika.
Ma'am?
I've shared my screen. Is it visible?
Yes,
Yes,
ma'am.
ma'am.
Okay, we are trying to understand, is 0 a rational number? Okay. Yeah.
Yes, ma'am. It is a
So
rational
now
number.
it is a rational number. Okay. So 0 means 0 can be expressed as 0 by 1. 0 can be, in fact, 0 can be expressed as 0 by 100 also. 0 can be written as 0 by 5. Okay, take whichever form you want. Now, is 0 an integer? Is this one an integer?
Yes, ma'am.
Yes.
Is 1 an integer? Is 1 an integer?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, it is an integer. So the numerator is an integer. The denominator is also an integer. And the denominator is not 0, right? The denominator is not 0.
Yes, ma'am.
So this is a rational number. If the numerator is an integer, the denominator is also an integer, but not 0, then that expression is a rational number. If somebody asks you, or if you have to answer this question, if the given number or the given expression is a rational number, what you should inspect? You must inspect the numerator. See the numerator. It should be an integer. Then see the denominator. That also should be an integer, but not 0. So if the numerator is an integer, the denominator is also an integer, but not 0, then that expression is a rational number. Is that clear?
Yes, ma'am.
Class?
Yes, ma'am.
Yes, ma'am.
Yeah, if the numerator is an integer, the denominator is also an integer. If the numerator is an integer, the denominator is also an integer, but not 0. Then that expression is a rational number. Now tell me, is minus 5 a rational number?
Yes, ma'am.
Yes, ma'am.
Can you see numerator and denominator in minus 5? What is the denominator in minus 5?
1, ma'am.
1. So write minus 5 as minus 5 by 1. Write minus 5 as minus 5 by 1. Now, is this an integer?
Yes, ma'am.
Yes.
Is this an integer?
Yes.
Yes. Yes, ma'am.
So the numerator is an integer, the denominator is an integer, and the denominator is not 0. So this is a rational number, which means this is a rational number. Minus 5 is a rational number. So which means all natural numbers, see here, all natural numbers are rational numbers. Why? Because 1 is 1 by 1, 2 is 2 by 1, 3 is 3 by 1, 4 is 4 by 1, 5 by 1, 6 by 1, integer by integer, integer by integer, integer by integer, correct? All are rational numbers. All natural numbers are rational numbers. Similarly, whole numbers. 0, 1, 2, 3, 4, 5, 6. Everything can be written as by 1. For 0 alone, you can give any denominator 1, 2, 3, 4, 5, anything. 1 by 1 by 1 by 1. So you can see everything is in the form integer by integer, integer by integer. The numerator can be 0. The denominator should not be 0. All natural numbers and whole numbers are rational numbers. Now coming to integers. Integers coming to integers. Integers also the same thing. By 1. You can write everything by 1. Everything by 1. Integer by integer, rational number. Integer by integer, rational number. So rational number is simply an expression of the form integer by integer. A rational number is simply an expression of the form integer divided by integer, where the denominator is not 0. Is minus 7 by 5 an integer? Is minus 7 by 5 an integer?
Yes, ma'am. Yes, ma'am. No, ma'am.
No, ma'am.
Ma'am, it's a rational number.
Children, integers, you should get this figure in your mind. Only what you can see here are integers. What you can see here are integers. Only this collection. It goes on like this and like this. This makes the collection of integers. Can you see minus 7 by 5 there? You
No,
can
ma'am.
see 0, 1, you can see 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then you can see minus 1, minus 2, minus 3, minus 4, minus 5. Where will you get minus 7 by 5? Minus 7 is there on the number line, but it's not an integer. Because what did we understand? What is a collection of integers? Natural numbers, their negatives, and 0. That's all.
Yeah.
See, children, last year you would have represented minus 7 by 5 on the number line. Minus 7 by 5 is present on the number line. But it's not an integer, because what do we have in the collection of integers? We have natural numbers. Then we have their negatives and 0. Minus 7 by 5 is not an integer. Is it a natural number? Minus 7 by 5, is it a natural number?
No, ma'am.
No, ma'am.
Is it a whole number?
No, ma'am.
No, ma'am.
Is it an integer?
No,
No,
ma'am.
ma'am.
Integer. No, you can see for yourself. What did we understand of an integer? Natural numbers, their negatives and 0. Minus 7 by 5 is not the negative of any natural number. It is not 0. How is it an integer? What is an integer? It should be a natural number. No, it's not a natural number. Or it should be the negative of a natural number. It's not a natural number at all. Then where can it be the negative of a natural number? It's not 0. Then how is it an integer? Minus 7 by 5 is not an integer.
Okay, ma'am.
Is minus 3 by minus 11 an integer?
No, ma'am.
Is minus 3 an integer?
Yes, ma'am.
Yes, ma'am.
How many of you say minus 3 is an integer?
Ma'am, minus 3 is an integer.
Yes, class, tell me. Is minus 3 an integer?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes, ma'am. Yes.
Raise your hand if yes. Is minus 3 an integer? Okay, all of you say minus 3 is an integer. All right. Very good. Minus 3 is an integer. Now, lower your hands. Lower your hands. Is minus 11 an integer?
Yes, ma'am.
Yes, ma'am.
Yes. Now is minus 3 by 11 an integer? Minus 3 by minus 11 an integer?
No, ma'am.
No, ma'am. No, ma'am.
Minus 3 is an integer. Yes. Minus 11 is also an integer. But minus 3 by minus 11 is not an integer. Then what can you call this? Minus 3 by minus 11 is nothing but 3 by 11. Minus gets cancelled, it's 3 by 11. Now, 3 is an integer, 11 is an integer, or you can say minus 3 is an integer, minus 11 is an integer, and the denominator is not 0. So what do you call minus 3 by minus 11? Jayant.
3 by 11, ma'am. Minus 3 by 11.
What is the term would you call it? A whole number, natural number, integer, rational number? What would you call it?
Ma'am, integer.
Krishmika, what is minus 3 by minus 11?
Rational number, ma'am.
It's a rational number. Is it an integer?
No, ma'am.
It's not an integer. It's a rational number. Because it's in the form, in simple words, it's in the form integer by integer. Let's say that. Let's understand that. See, you don't say this in your school, in your class, okay? In our discussion, that's the simplest way you can remember. Integer by integer form it is. Yes or no? Minus 3 by minus 11. Integer by integer, right? It is?
Yes, ma'am.
Yeah.
Yes,
so
ma'am.
Yeah, so it is a rational number. It is a rational number because it's in the form integer by integer. It's a rational number. Now, see, now when you take yourself, for example, you are somebody's friend, somebody's brother, or somebody, see, you are one person, but you will be called differently in different relations. Somebody might call you Anna or Akka, or someone else might call you Chitti or Mama. You know, you are one person, but you will be called differently by different people. You may be somebody's friend, somebody's brother, somebody's sister, but you are one person. You're one person. You're somebody's uncle. Later in life, you'll become somebody's grandfather. You'll become somebody's father or mother. But you are one person. Similarly, one number can have different names. Now, one number can have different names. See here. Now, when I write 5, 5 is a natural number. Yes. 5 is also a whole number. 5 is also an integer. 5 is also a rational number. So don't think if 5 is a natural number, it cannot be something else. It can have different names. It should just satisfy the definition. I hope we understand that. Just because 5 is a natural number, you cannot, because these are some mind blocks, you know, we feel, no, 5 is a natural number, then how can it be an integer? Not like that. 5 is one number, like you are one person, 5 is one number, but you can call it by many names. So when you take this number 15, 15 is a natural number, 15 is a whole number, 15 is an integer, 15 is a rational number. Because 15 is 15 by 1. It's integer by integer. It's integer by integer, so it's a rational number. Now, like that, tell me. Now, tell me for minus 45. Is it a natural number?
Yes, ma'am.
Yes, ma'am.
No. Sorry, ma'am. No, ma'am.
Yeah, this is what happens, children. Now, you might all be wondering, maybe you're wondering, why is she doing this for such a long time, so elaborately? Just to remove, just to make your mind very clear about these terms. Though we've been seeing all this from 4th standard, see, we still tend to make a mistake. Is minus 45 a natural number?
No, ma'am.
No.
No, ma'am.
No, ma'am.
Is minus 45 a whole number?
No, ma'am.
No.
No, ma'am.
Is minus 45 an integer?
Yes, ma'am.
Yes, ma'am. Yes.
Yes. Is minus 45 a rational number?
Yes, ma'am.
Yes, ma'am.
How do you say it's a rational number? Because you can write by 1. Then it is integer by integer. It's a rational number. What is a rational number? Integer by integer is a rational number. Okay, so I think it should be, this explanation should be good enough for you to be clear with these terms. Can we proceed, children?
Yes, ma'am.
Yes.
Shall we move
Yes,
on?
ma'am. Yes, Yes. ma'am.
Okay. Now this. Now 10 by 20. Now 1 minute. I just want to repeat the, the definition of an integer, because this is what is. Now what should I mark for to show integers?
0, ma'am.
0.
1, 2,
1, 2, 3.
5, 6, 7, 8. And in the negative side, -1, -2, -3.
Minus 2, -3,
Now
minus
what
4,
these
minus
are what? These are what?
natural.
Numbers.
Natural numbers. What should I write on this side? They're negatives. What should I
Minus
write?
1, minus 2, minus 3, minus 4.
Yeah, I must write the negatives of the natural numbers. -1, -2, -3, -4, -5. I must write their negatives. And I must also show 0. Natural numbers, their negatives, including 0, forms the collection of integers. Is 1 by 2 an integer?
No, ma'am.
It's not an integer. 1 by 2 is not an integer. Because, see, if it's an integer, it should be a natural number, or it should be a negative of, it should be the negative of a natural number, or it should be 0. If it should be an integer, it should be a natural number. No, this is not a natural number. Okay, then it should be the negative of any natural number. No, it's not the negative of any natural number. Okay, is it 0? No, it's not 0. Then it is not an integer. See, I told you, you should use the definition to understand. Now, who can tell me the definition of an integer the way I said now?
Ma'am.
Ma'am, natural numbers and their negatives.
That's all?
And 0, ma'am.
Okay. All of you tell me one by one. Madhumita, good. Yes, next.
Ma'am, an integer is a number.
Yeah, Raja now. Yes.
An integer is a number. I'm sorry, ma'am. A number is an integer if it is either a natural number or or the negative of a natural number or 0.
Yeah. Right. Very good. Yes, Gautam. In very simple words.
Ma'am, integer plus integer is equal to rational number.
Integer by integer is a rational number, but we are discussing integers now. Gautam, what is an integer?
Integers is equal to rational numbers. Like that only, ma'am.
Vishmika?
Ma'am, natural numbers and its negative including 0.
Yeah. All natural numbers are integers. Their negatives, the negatives of natural numbers are integers, and 0 is an integer. So it should be one of these, it should belong to one of these three. It should belong to one of these three. If it's an integer, is it a rational number? Is it the negative of any rational number? Or is it 0? Natural numbers, their negatives, including 0, forms a collection of integers. So when you're asked a question like -3 by 5, is it an integer? So this one is not a natural number. It's not the negative of any, it's not a natural number, then it cannot be its negative also. It's not 0 also, so it's not an integer. -3 by 5 is not an integer. What is -3 by 5? It's a rational number. -3 by 5 is a rational number because -3 is an integer. You can see it here. 5 is an integer. You can see it here. Integer by integer is a rational number. But this is not an minus 3 by 5 is not an integer. Minus 3 by 5 is a rational number. Now coming to the simplest form of a rational number. Simplest form of a rational number. Now 10 by 20 is a rational number because the numerator 10 is an integer. The denominator 20 is an integer. So 10 by 20 is a rational number because it has the integer by integer form. Because it has the integer by integer form. So it's a rational number. 10 by 20 is a rational number. Integer by integer is a rational number. Okay, but this rational number is not in its simplest form. How do you simplify? How do you put this in the simplest form?
Ma'am, 1 by 2.
1 by 2. 10 ones are 10 twos are 1 by 2. 10 by 20 is equal to 1 by 2. So 10 by 20 is a rational number, but it's not in its simplest form. It's not in its simplest form. 10 by 20 is a rational number. It's not in its simplest form. What is the HCF of, yeah, what is the HCF of 10 and 20? What is the HCF of 10 and 20?
10, ma'am.
10. What is the HCF of 1 and 2?
1, ma'am.
Yeah. If a number is if a rational number is in its simplest form, then the HCF of the numerator and denominator will be 1. If a rational number is in its simplest form, that means the HCF of the numerator and denominator will be 1. Let's take some more examples. So 35 by 50. I'm taking simple numbers so that all of us can solve. 35 by 50. 35 by 50 is a rational number because 35 is an integer, 50 is an integer, and integer by integer is a rational number. So 35 by 50 is a rational number, no doubt there. But is 35 by 50 in the simplest form?
No, ma'am.
Is 35 by 50 in its simplest form?
No, ma'am.
No, ma'am.
Simplest form. So what is the HCF of 35 and 50?
5, ma'am.
5. Now put it in its simplest form, 35 by 50 in the simplest form.
7 by 10.
7 by 10, ma'am.
7 by 10. Now what is the HCF of 7 and 10?
1, ma'am.
1. Now, if the HCF of two numbers is 1, then the two numbers are said to be co-prime. So you'll be coming across a few new terms. You will get used to them once we use it repeatedly, you know. So now your responsibility is to just understand as I'm saying different things. You don't worry as to how to remember them. But then when we keep using these terms regularly in the class, this is a vast chapter. Number systems is a vast chapter. So we'll be using these terms so many times when we work different problems in this chapter. Then you know, some 1 month later, when you think of this class, you will think those terms are so easy for you. The terms which you feel today are, you know, maybe difficult to remember. After a month, they'll all become, you know, some kind of a daily language for you. Okay, so now I said I was telling you about co-prime numbers. Co-prime numbers. So now what are we discussing? We are discussing about the simplest form of a rational number. 35 by 50 is a rational number. No doubt it is a rational number, but it is not in its simplest form. The simplest form of 35 by 50 is 7 by 10. Why is 35 by 50 not in the simplest form? Because the HCF of the numerator and denominator is not 1. It is something else. It's not 1. So it's not in the simplest form. Then how do you know that it's in the simplest form? If the HCF of the numerator and denominator is 1, that means that rational number is in its simplest form. So now when you write 2 by 8, it's not in the simplest form because the HCF of 2 and 8 is 2. So you cancel 2 1s are 2 4s are This is in the simplest form. 1 by 4 is in the simplest form because the HCF of 1 and 4 is 1. You cannot cancel it any further. You cannot cancel it any further. You cannot simplify it any further. Okay. So when we say 100 by 120, 0, 0 cancels. 2 5s are 2 6s are. So 5 by 6 is the simplest form of 100 by 120. 5 by 6 is a rational number. Is a rational number in its simplest form. Am I audible and clear, children?
Yes, ma'am.
Yes.
All right. So 5 by 6 is a rational number in its simplest form. 5 by 6 is a rational number in its simplest form. All right. Now you understood what a rational number is and also the simplest form of a rational number.
Yes, ma'am.
Yeah, co-prime numbers. Two numbers are said to be co-prime. If their HCF is 1. If their HCF is 1. Now when we take the numbers 15 and 16. Okay, let's find what is the HCF of 15 and 16? What is the HCF of 15 and 16?
1, ma'am.
1. The HCF of 15 and 16 is 1. Is 15 a prime number?
No,
is 15
ma'am.
a prime number?
No, ma'am.
No, ma'am.
No.
15 is not a prime number. Is 16 a prime number?
Yes,
No,
ma'am.
ma'am. No, ma'am. No, ma'am.
Sorry, ma'am.
Ma'am.
16 is also not a prime number, but they are co-prime numbers because their HCF is 1. So two numbers which are co-prime need not be prime numbers. You can see that in this example. What is the definition of co-prime numbers? Two numbers are said to be co-prime if their HCF is 1. This is the definition. Numbers are said to be co-prime if their HCF is 1. The HCF of 15 and 16 is 1. So 15 and 16 are co-prime. But in these two numbers, none of them are prime numbers. 15 is not a prime number. 16 is also not a prime number. That's okay. They need not. They may be prime numbers. They may not be prime numbers. They may be a combination of a prime and a non-prime number. The numbers can be anything. Their HCF should be 1. If their HCF is 1, they are co-prime. That's all. Stick to the definition. Now, if they ask you the HCF of, some 21 and 22. The HCF of 21 and 22. 21 is not a prime number. 22 is also not a prime number. But the HCF of 21 and 22 is 1. So they are co-prime numbers. Two numbers are said to be co-prime if their HCF is 1. So now we use this definition for the simplest form of a rational number. Simplest form of a rational number. Simplest form of a rational number. A rational number is said to be in its simplest form if I say A by B. Now A by B is said to be in its simplest form if the HCF of A and B is 1 or if A and B are co-prime integers. That is their HCF is 1. When I say co-prime integers, that means their HCF should be 1. A rational number A by B is said to be in its simplest form. You can say if the HCF of A, B is 1. If the HCF of the numerator and denominator is 1, that means that's the simplest form. That means you should not be able to cancel it any further. That's all. You know it. So using this technical term, a by b, a rational number a by b is said to be in its simplest form if a and b are co-prime integers. If a and b are co-prime integers, that means their HCF is 1. Co-prime integers meaning their HCF is 1. If a and b are co-prime integers, that is if a and b, the HCF of a and b is 1. That means you cannot cancel it any further. If the HCF is 1, you cannot simplify it any further. So this is about the simplest form of a rational number. So we saw natural numbers, we saw whole numbers, we saw integers, we saw rational numbers, we saw the simplest form of a rational number. We understood the meaning of co-prime numbers. I'll share all these notes later. Co-prime numbers.
Yes, ma'am.
Yeah. Okay. Now let's consider some rational numbers. Now, for example, let's say 3 by 8. All right, 3 by 8. 3 by 8. There's 3 by. Children, please, all of you give me one answer because think and say, don't answer. All of you think. 3 by 8, all of you think. Get the answer in your mind. Natural, whole, integer, rational number. Get the answer in your mind. Don't say anything now. Don't say anything. 3 by 8. Let me show the screen. 3 by 8 class. Good evening, Danya.
Good evening, ma'am.
Danya, you were late to join the meeting, right?
Yes, ma'am. Actually, I'm in a outstation, ma'am. So kindly excuse me, ma'am. Next class I will join on time, ma'am.
Okay, darling. Okay, yeah. Thank you. Yeah.
Thank you, ma'am.
Yeah. So children, look at this 3 by 8. All of you saw the number 3 by 8?
Yes, ma'am.
Yes, ma'am.
Yeah. Now, Gautam, tell us, what would you call 3 by 8? Will you call it a whole number, natural number? What would you call it? 3 by 8. Three by 8 is a
Natural number, ma'am.
no. 3 is a natural number. 8 is a natural number. 3 by 8. 3 by 8 is not a counting number.
Whole numbers.
No, 3 by 8 is not a whole number. Yes, Giants.
Ma'am, rational number.
Why do you call it a rational number?
Ma'am, because there's a integers, ma'am.
Correct. Very good. Express clearly. I know you understood, but tell me clearly. Because the numerator 3 is an
Integer.
the denominator 8 is an
Integer.
integer by integer is a rational number. Correct?
Rational number. Yes, ma'am.
Yeah. So 3 by 8 is a rational number. No problem, Gautam. You will understand. Since we are learning many terms today, maybe you're confused. You know it, but you're not. You did not come out with the right answer. That's okay. Okay, class 3 by 8 is a rational number, right?
Yes, ma'am.
Yes, ma'am.
Now,
Yes,
don't
ma'am.
you
Yes.
think it's division? Yeah, don't you think it's division? 3 by 8. 3 by 8. Okay, so you want to divide it, okay? Because what is 3 by 8? Yeah, it's a rational number. That means you can find its value. You can find the value of this rational number. See, now if you have the rational number 5 by 2, 5 by 2 rational number, you know it is 2.5 or 2.5, correct? 2.5. Without division, you know. You don't have to divide this at all. You know it's 2.5. You know it's 2.5. Now 3 by 8, we don't know what is 3 by 8. So we have to divide. So 3 becomes the dividend, 8 becomes the divisor. Now 0 point, please. Now this division, I don't know. I can't teach you. I'm not teaching you this division. You should know this. So now tell me, 8 3s are 24. 6 is the remainder. You can add a 0. 8 7s are 56. 4 is the remainder. You can add a 0. 5s are 40. 0 is the remainder. This division we have learned, I think, in 4th and 5th standard children. So you should know this. So 3 by 8, the decimal expansion of 3 by 8 is 0.375. 0.375. 3 by 8. See, we've been doing this now. When it is 11 by 2, you know 11 by 2 is 5.5, and 5.5 means 5.5. You know this. You know 1 by 4. 1 by 4 is 0.25. You know certain things you know. 1 by 2. What is 1 by 2, children? What is 1 by 2? Yes. 9th standard. What's 1 by 2?
0.5, ma'am.
0.5. What's 3 by 4? Yes, class. 3 by 4. 3/4.
0.75, ma'am.
Yeah, 0.75. 0.75. So 3 by 8. See, all this also we get by division. How do you know 3 by 4? 3 by 4. So 0.4 sevens are 28. 2 is a remainder. You can add a 0. 4 5s are 20. 0 is a remainder. So 0.75. The quotient 0.75. So the value of 3 by 8 is 0.375. See, it's division, no? So 3 by 8 is a division, integer by integer, integer divided by an integer. So you can do the division and you can find the quotient and the remainder. If the division does not come to an end with a 0 remainder, then you will have a remainder also. Okay, now we are talking about divisions where the division comes to an end with a 0 remainder. Children, we took 3 by 8. And we all understand that 3 by 8 is a rational number. Next, we divide 3 by 8. We see that the division comes to an end with a 0 remainder. And the quotient is 0.375. So, when you divide P by Q meaning the rational number, P divided by Q. When you divide P by Q, that is here you divide 3 by 8. And if the division comes to an end with a 0 remainder, the division comes to an end with a 0 remainder. When you continue the division, remainder is 0. Then that's it. The division has come to an end. How do you know the division has come to an end? Because remainder is 0. So it's come to an end. Division has come to an end. And when you look at the quotient is 0.375. That's all. So we say that 0.375 is a terminating decimal. Why terminating decimal? Terminating meaning ends somewhere. It ends. It terminates. Terminates meaning it ends. Terminating decimal meaning the decimal comes to an end somewhere. 0.375. That's all. When will the quotient look like this? Only when the remainder is 0. Am I audible now, children?
Yes, ma'am.
Yes, ma'am.
Yes.
I was not audible for some
Yes,
time,
ma'am.
right?
ma'am.
Yes, ma'am.
Yeah. No, I was not talking anything then. Don't worry. You didn't miss anything. Yeah. Just a second. So I said 3 by 8. When we perform the division, 3 is 24, 6, 0, 7 is 56, 4, 0, 5 is 40, 0. Division comes to, when you get 0 as a remainder, you're like, oh, it's over. So division is over, meaning the remainder is 0. Then look at the quotient. It's a terminating decimal. 3 by 8 is equal to 0.375. Children, I have lots to say regarding, rational number. I mean, not that I have lots to say. There is lots to learn in the introduction part of this chapter. Please be very careful. Is this much clear, children? Is this division? The division comes to an end with a 0 remainder. Terminating decimal. Is all this clear?
Yes, ma'am.
Yes, ma'am.
Okay. Now this is a case where you divide and the division comes to an end with a 0 remainder and the quotient is a terminating decimal. Now let's take another example. Let's take another P by Q. Okay, let's take another P by Q. I'll have to clear the screen. Let's take another P by Q. So now supposing 2 by 7. 2 by 7. So let's divide 2 by 7. Okay, so we're going to start. It's going to be lengthy. So 2 by 7. All right. So it's not sufficient. So you need to place a decimal point, add a 0. 0 point is the preparation. Now we are ready to start. 7, how many times 20?
2 times 14, ma'am.
2 times 14. Very good. What's the remainder?
6, ma'am.
I should write it very tiny because the screen will not be sufficient. 1 minute, 1 minute. Okay, this can be big. 1 minute. Yeah, this can be big. Now this division, no, let me write it very small. 2 by 7, okay, so. Yeah, now you said what? 2s are 14. 14, what's the remainder?
6, ma'am.
6.
Okay, and then free 0, you can add one free 0. Then? Yes, children, divide.
8 are 56, ma'am.
8 are 56. What's the remainder?
4, ma'am.
4.
4. Can you add a 0? Yes, every stage you must add a 0. Then 7. How many times 40? 35. Remainder?
5, ma'am.
0. 7,
7,
7.
49.
49. Yeah, tell along with me. 1 is the remainder. You can add a 0.
1s are 7.
1s are 7.
3
What's
remain.
3 is the remainder. Add a 0.
0.
4s are
28.
8. 2 is the remainder. We started with 2 only. You remember we started with 2 and see we got back 2. That means all this will repeat. See, we started with 2 only. 2 divided by 7. We started with 2. Then we got remainder 6. We got remainder 4. We got remainder is 6, not 60. 0 we added later. 6 was the remainder. We started with 2. We got 6 as the remainder. Then we got 4 as the remainder. We got 5 as the remainder. So here we got 6 as the remainder. And here we got 4 as the remainder. Here we got 5. Here 1. Here 3. And 2 again. We started with 2. We've got 2 again. Now what will happen? Add a 0. Add a 0. Then again the same thing will repeat. 2s are
14.
2s are 14. Now see what's happening. Same story again. Same story again. 7 2s are 14. What's the remainder?
6.
6. Didn't we get 6 remainder earlier? Didn't we get remainder 6 earlier?
We got, ma'am.
Yes.
Yeah. So now see we add a 0. Again 8s are 56. What's the remainder?
4, ma'am.
4 is a remainder. See exactly that we got here. 6 and after that we got 4. Same thing. 4 is a remainder. Add a 0. 5s are 35. 5 is a remainder. That's what we got here. 5 is a remainder. So what do you understand from this? The division is going to go on and on. The division is not going to come to an end because the same set of remainders. We started with 2. 2, 6, 4, 5, 1, 3. Again 2, 6, 4, 5, 1, 3. Again 2, 6, 4, 5, 1, 3. Same thing is going to happen. See here, 2. We started with 2. 6. No, you don't have to start with 2. You can think of this also. 6, 4, 5, 1, 3, 2. Again 6, 4, 5. You'll get 1, 3, 2. So 6, 4, 5, 1, 3, 2. Same thing. 6, 4, 5, 1, 3, 2. These remainders will keep happening. You think you will just wait when you can finish the division, but you can never finish this division because when you say that the division is over, only when you get 0 remainder. No, you will never get 0 remainder here. You will get 6. Am I audible and clear, children?
Yes,
Yes.
ma'am.
Yes.
Yeah, you will get 6. You will get remainder 6, or you will get remainder 4, or you will get 5, or you will get 1, or you will get 3, or you will get 2. You will get 6, 4, 5, 1, 3, 2. Again, the same thing will repeat. 6, 4, 5. There's no space. You continue, you will get the same thing. 1, 3, 2. Again, 6, 4, 5, 1, 3, 2. Again, 6, 4, 5, 1, 3, 2. So this is going to go on and on. The division will not come to an end with a 0 remainder. What did we see earlier in the case of 3 by 8? In the case of 3 by 8, in the case of 3 by 8, what was 3 by 8? Who can say what is 3 by 8?
0.375, ma'am.
0.375. 0.375. Terminating decimal. I'll just write TD. Terminating decimal. Because the division came to an end with a 0 remainder. Now here, what happens? What happens? How many remainders repeat? How many remainders? 6 remainders, right? 6, 4,
Yes,
5,
ma'am.
1, 3, 2. Again 6, 4, 5, 1, 3, 2. 6 remainders will keep repeating. The same pattern will happen again and again. Remainder will never be 0. So this is a case where you divide P by Q and the division does not come to an end with a 0 remainder. You will see that one digit, like sometimes one single digit, one that is the remainder might be 3, 3, 3, 3, 3. The remainder will be the same digit everywhere, or a set of digits like this. Now, if you take, I'll just do another division. See here. See here. So supposing we divide 1 by 3. Okay, supposing we divide 1 by 3. What's 1 by 3? 3 3s are 9. 1 is a remainder. Add a 0. 3s are 9. 1 is a remainder. Add a 0. 3s are 9. 1 is a remainder. Add a 0. So here the remainder is continuously 1. The remainder is 1. Everywhere it's 1. So either the same remainder will keep repeating. Either the same remainder repeats, or a set of remainders like this 6, 4, 5, 1, 3, 2. See, you will get different sets of remainders. Not that everywhere 645132 will repeat. So like this, either a single digit, meaning a single number like this, 1, 1, 1, the same number, 1 repeats itself. The remainder 1 repeats itself. See here, the remainder is 1 everywhere. Every stage you get remainder 1. So sometimes like this, here also the division does not come to an end with a 0 remainder. Here also the division does not come to an end with a 0 remainder. Now what's happening? What do you see in this division? The remainder is 1 everywhere. Everywhere the remainder is 1. Let me do the division again for you in case you don't understand the division. Let me take maybe a different number. Let me take so let me say take 14 by 9. 14 by 9. Okay. Let's divide 14 by 9. 14 by 9. 9 ones are 9. What's the remainder? 5.
5, ma'am.
Keep a point, add a 0. 9 fives are 45. 5 is the remainder. 5s are 45. 5 is the remainder. Add a 0. 5s are 45. 5 is the remainder. So from this you can make out this division is not going to end with a 0 remainder because remainder is 5. Here also 5. Here also 5. So the remainder is the same remainder is repeating. The same remainder repeats itself. So this is a case where the division does not come to an end with a 0 remainder. So if you look at the quotients, see if the division does not end, the quotient also will not end. The digits in the quotient also will not end. If the division does not end, the digits in the quotient also will not end because you can keep writing digits in the quotient. You can keep dividing and keep writing the digits in the quotient. That means when the division does not come to an end with a 0 remainder, you will get a non-terminating decimal. Non-terminating decimal meaning a decimal that does not come to an end. Okay, but there is something special about the decimal. It will be a non-terminating but repeating decimal. Because see the 1, 5, don't you think 5? What is the quotient? What do you think the quotient will be? 1.5555 will keep going on, right?
Yes, ma'am.
The quotient is not just 1.555. It'll go on like this. We just stopped with this 5 because we realized that the division is not going to end. So the quotient will go on like this 1.555555. It goes on like this. All right. So the shortest way of writing this or the short form is 1.5 recurring like this. When we say 1.5, it's just 1.5. When we say 1.5 and put a bar on 5, it means 1.5 recurring. 1.5 is 1.5. But when I say 1.5 and I place a bar 1.5 recurring means 1 point. This digit 5 keeps happening. The digit 5 keeps happening. Are you seeing what I'm writing on the screen?
Yes.
So here we say that the quotient is a non-terminating but repeating decimal because that digit 5 keeps repeating. Now here what are the digits that repeat? 285714. Again 285714. Again 285714. Again 285714. So you can see it here. I'm not saying that. You can see it here. 285714. Again 285714 will keep happening. So that means 2 by 7. 2 by 7 is equal to 0.285714 recurring. Because 28, why did I put a bar on top of 285714? Because the same digits in the same order will keep happening. The same digits 285714 will keep repeating. Why will they keep repeating? Because division will not end with a zero remainder. So we say that when the division does not come to an end, the quotient will be a non-terminating. Because the division is non-terminating, the division does not end. So the quotient also will not end. The digits in the quotient will not end. Non-terminating, but repeating decimal. Repeating because the digits 285714 will keep repeating. Not always, many digits should repeat. In this case of 14/9, only one digit is repeating. Only one digit is repeating, 1.5 recurring. So these are the two cases. These are the two cases. We know that rational numbers are of the P by Q form. When you divide P by Q and the division comes to an end, when you divide P by Q and the division comes to an end, the quotient will be a terminating decimal. When you divide P by Q and the division does not end, it goes on and on, then the quotient will be. So what you see in this case is there will be one remainder which is going on repeating, or a set of remainders that will repeat. Either one remainder will keep happening or a set of digits, a set of remainders will keep repeating. Accordingly, in the quotient, if one remainder is repeating, in the quotient also one digit will repeat. If a set of remainders are repeating, in the quotient also a set of digits will repeat. So the first case is where the division comes to an end with a zero remainder, the quotient is a terminating decimal. If the division does not come to an end, the quotient will be a non-terminating but repeating decimal. So when you divide P by Q, the division can come to an end and the quotient is a terminating decimal. Or when you divide P by Q, the division does not end and the quotient will be a non-terminating, repeating decimal. Why repeating? Because the quotient is like, what did we do? 2 by 7, right? 2 divided by 7. What did we get? 2 by 7. We got 0.285714. Repeating. It's non-terminating because it will never end. It's repeating because the digits 285714 will keep happening. This means the other way of writing this is 0.14. 285714. 285714, and you can put dots like this. That means it goes on forever. That means non-terminating. Repeating because the same digits repeat. So repeating. Do we understand the difference? But why did we say it's a terminating decimal here? Because when I said 1 by 2, it is 0.5. That's all. It terminates. Finished. 0.5. No more digits. 0.5. That's all. When I say 0.375, that's all. 0.375. Finished. Terminating decimal. It ends. But when I say 0.285714, 285714, it goes on like this. That means it's going on. It's non-terminating. But why is it repeating? Because a set of digits keep repeating. It's called a non-terminating repeating or a recurring decimal. Repeating, recurring, both are the same. Repeating, recurring. You can say non-terminating repeating decimal or a non-terminating recurring decimal. Both are the same. So rational numbers have only two kinds of decimal expansions. Rational numbers have a terminating decimal expansion or a non-terminating repeating decimal expansion. Terminating decimal expansion, terminating decimal, or it is a non-terminating repeating or recurring decimal. Because when you divide, only these two things can happen. When you divide, only these two things can happen. What can happen when you divide? What can happen when you divide? Either the division will come to an end with a zero remainder, or the division will not come to an end with a zero remainder. Am I audible and clear, children?
Yes, ma'am.
Yes.
Okay. What will happen when you divide? Yeah. What will happen when you divide? When you divide, the division may come to an end with a zero remainder or may not come to an end with a zero remainder. So accordingly, you will have these two kinds of decimal expansions. The quotient will be a terminating decimal when the division comes to an end with a zero remainder, or the quotient will be a non-terminating repeating decimal when the division does not come to an end. It does not come to an end with a zero remainder. So these are the two kinds of decimal expansions a rational number has. Then the third one which we have to discuss, which we shall discuss in the next class, is a non-terminating, non-repeating decimal. So these are the three different decimals we have. I'll just finish in 2 minutes. Terminating decimal, terminating decimal, non-terminating, repeating or recurring decimal, non-terminating, non-recurring or non-repeating or non-recurring, okay, non-recurring decimal. Terminating decimals, non-terminating, it will go on, but repeating or recurring decimal, non-terminating, non-repeating decimal. So the first two decimals are rational numbers. This one is an irrational number. The last one, these are the three types of decimals we have. The first two decimals are rational numbers, because you will get this when you divide p by q. You will get this also when you divide p by q. Here the remainder is 0, here the remainder is not 0. And the third one, non-terminating, non-repeating decimal, is an outcome of an irrational number. We'll see that in the next class. Is that fine, children?
Yes, ma'am.
Yes, ma'am.
Okay, so whatever
Yes,
we have
ma'am.
discussed, yeah, I'll just show you the slide so that you don't find it new. I'll be sharing these slides with you on WhatsApp, because some of them have not taken the class today. Yeah, I'll be sharing these slides with you. So there may be a few terms which are new to you. That we'll see in the next class. Whatever I share on WhatsApp, you please write. You can take a screenshot if you want, children. Those who want to take, I'll also share on WhatsApp. Those who want to take a screenshot can take it now.
Taken, ma'am.
Yeah. So here we have not discussed irrational numbers. Don't worry, we'll see that in the next class, but write down that. Maintain a separate book for this class. Maintain a separate book. It should be a new book. Now I cannot force you. It's an online class. Make sure you have a new book. A ruled book is better than an unruled book, because in a ruled book you can write in a more organized way. There are lines and you can write on the lines. When it's unruled, you may not be presenting your work neatly. So preferably a ruled book. If you have many unruled books at home and your parent, your father or mother wants you to use the same book which is at home, please use it. No arguments. If you're going to buy a new book, please buy a ruled book. Write all this. So 1, 2, 3. This is the third one. Please take a screenshot of this one.
Taken, ma'am.
This one also.
Taken, ma'am.
So that's all. Okay, this one also. We discussed this. Yes, this also, children. This one is your homework. You can see the heading there.
Taken,
Say
ma'am.
true or false. Say true or false, but I have not answered it. So you please complete this. We'll discuss the answers in the next class. I think you can answer only till here. We can answer you. I think you can answer only till here. If you get all the answers correct till here, very good. If you are able to answer 1 to 9 correctly, very good. Because we still have to understand the terms real number and irrational, all that we have to still understand. But write down all the statements in your book and answer how much ever possible. So when you're writing true false, use a pencil. Write the statements in a pen using a pen, but write your answer in a pencil. So that if in case you're wrong, you can erase that and then write the correct answer with a pen. All right, children. So 1 minute. Yeah, children. So that was it for today's session. I hope all of you understood. Tell me one by one. Krishmika.
Yes, ma'am.
Giant understood. Krishmika.
Understood, ma'am.
Okay, and the old students, Danya, Madhumita, and Raja.
Understood.
Yes, ma'am. It's clear, ma'am.
Ma'am. Understood, ma'am.
Thank you. All right, children. So that's it for today's session. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you.